Okay, good morning, guys. We are doing two types of solids today, so pyramids and then cones. They're put together for a reason. They are very similar to each other. They have this new idea of this thing called a slant height, which we're going to get into in a minute. So today's video shouldn't be as long as yesterday because I am cutting down the number of problems I do. So just let me know after this video if you need more help for today's assignment. Like I said, that should just be like classwork. If you need any help, you'll just have to ask me for help, just like you would in a typical class period, okay? So looking at pyramids, pyramids are these solids that have one base and then all of the other non-base faces are meeting at a single point, okay? So we have three different variables that we're going to be using. We have this italicized L, and that italicized L, you might think it might stand for length, but it actually stands for the slant height, okay? So the slant height, if you think about anything that's at a slant, it's kind of like at a diagonal. It's going to be the height from the base to the top of the pyramid, but it's on a slant, okay? So it's actually like alongside of one of the faces, whereas we also still have the height, where the height is just the exact height from the middle of the base to the very top point where all the faces are meeting each other. And typically, like you see here, we don't have the actual height in the calculation, but it is going to be useful in sometimes finding that slant height, because if you can kind of see, you're going to be creating some right triangles with this height and half of the base, okay? So we'll get into a lot of problems like that in just a second. P is still standing for the perimeter of the bases, and then uppercase B is standing for the area of the base, just like it was in the last video. Okay, so the only difference is this L is standing for slant height, and that's going to be true for not only pyramids, but also in cones. So we'll get a lot of practice with that. So starting with number one, I'm given the bases are going to be congruent to each other, it looks like. So since this base is 8 and this base is 8, that means it is a square base. So then all of these sides will be 8. I'm just going to make little tick marks. So we know my perimeter would be 8 times 4, or 8 plus 8 plus 8 plus 8. So my perimeter is 32. My slant height is coming from this diagonal line that's going from the base to the very top of the where all the faces are meeting, and it's alongside of one of the faces. So that's going to be my slant height. Is 11.7. And then lastly, I need to find the base area. The base is just a square, so I'm just going to take 8 squared, or 8 times 2, or 8 times 8, and so the base area is 64. Okay, so now I have everything that I can plug into my surface area formula. And so my surface area is the lateral area, so that 1/2 of slant height, 11.7, times the perimeter of the base, plus the base area, which is 64. And remember how in the last video we had to do plus 2b? That was because we had two bases. In pyramids, you're only going to have one base, so that's why we only have to add the base once. We don't have to multiply it by 2 in these formulas. The same is going to apply for the cone. So after I plug in all of this into my calculator, I get a surface area of 251.2 meters squared. Okay. So again, my perimeter was just taking all of the sides of the bases and adding them together. And a lot of these you're dealing with a square base. If it only tells you 2 of the sides, that you're just going to know that it's a square base because the opposite sides should be congruent to each other, just like in number 2, also number 3. And then the slant height is coming from the base to the top of the pyramid, and it's along one of those bases. And then the base area is just taking the area of that base. In this case, it was a square, so we took 8 squared to get 64. Okay, you're going to do number 2 for homework, or on that attendance quiz today. So I'm going to move to number 3. So in number 3, right away, I noticed that I'm not actually given that slant height. Instead, I'm given the actual height of the pyramid. So what I want is this actual height right here along the diagonal. So I'm going to kind of make another triangle of what this might typically look like. So this is my slant height. I know the height of the triangle from the middle is 3 feet. And then we have to think about what is this length, okay? So this length is coming from just drawing a line straight out from the middle to the base edge. So if I were to draw a line just right out there, that's where my triangle is coming from. And if you look, I'm in the center of the pyramid. So if I am in the center, that means I'm halfway along the base. So I only want half of my base length for this side length of the right triangle. So I'm going to take half of my base length, which is 16. So half of 16 will give me 8. So that means this side of the right triangle is 8 feet. And so now I can use Pythagorean theorem to figure out what my actual slant height is. So I'm going to take 3 squared plus 8 squared equals, you can use c squared or l squared, whatever you want to use. Those are the same thing. And 8 squared plus 3 squared gives me 73. And then I'm going to take the square root of both sides to get a slant height, or C value, of 8.5. So I know my slant height is going to be 8.5. Make sure I put a decimal in there. Next, I want to find the perimeter of my base. So the perimeter would be going all the way around here. So it's really going to be 16 times 4, which would give me a perimeter of 64. And then I need to find my base area, which my base area is a square, so it's just going to be 16 squared to give me 256. So now I'm just going to take all of these variables and plug them into my surface area formula to get surface area is 1/2 times 8.5 times 64 plus 256. And so my surface area comes out to be 528 feet squared. Okay, so obviously the new part with number 3 is finding that lateral area, lateral side length. Just remember that the height is important. So the height from the middle of the pyramid is very important. That should be one of your legs. And then you need to take half of the side length for your base to find that other leg. And then you'll just use those to solve for L to plug into the Pythagorean theorem. Okay? So I'm going to do number 4 as well. I think number 4 will be really helpful for number 5. Okay, so if it looks like I just cut this video really weird, it's because I did. I just looked at how I explained number 4 and realized that it made no sense. So I'm going to do a better job this time. With number 4, okay, there right away, I see two things that look kind of confusing. I see this dotted line and I see this dotted line. So this is when it turns into, you have to really pay attention to what your base is. Your base is going to always be the equilateral shape at the bottom of this pyramid. So right away I see this is 10 inches, this is 10 inches, and this is 10 inches. So I'm going to highlight this as my base. And when I look at that base, now I'm going to see what diagonal line or what dotted line is going from my base to the apex of the pyramid, so the top of the pyramid. Well, that has to be this line here, okay? See how this dotted line, it only goes from one end of the base to the other end of the base? So since this dotted line is actually going to the top of the pyramid, that's why this 6.7 is my slant height and not this 8.7 over here. So that is a big thing to look out for. That kind of looks confusing on this one. I think number 5 does a much better job of showing you which one is which. I just think number 4 is not the best picture. And I think I even go over, after I get done with this part of the video, I even go over how to label your picture with number 5. So moving on with number 4, this 8.7 is going to come in handy when I have to find the area of that base. So before I get to that, I do need the perimeter of my base. The perimeter is coming from 10 plus 10 plus 10. So my perimeter is 30. And then the area of the base is going to have to be 1/2 times the height times the base length, okay? So if I just draw this triangle out again, it would be something like this. We're going to pretend it's equilateral. That is awful drawing. That's a little bit better. And then there's this 8.7 dotted line in the middle. What that 8.7 line is that is my height of my base. Okay, so that's actually going to be my height for this base formula. And then all of my bases are actually 10. So this side, the base would be 10. So my area of my triangle has to be 1/2 times 8.7 times 10 to get an area of 43.5. Okay. And now I'm just going to use my surface area formula of 1/2 the slant height of 6.7 times the perimeter of 30 plus the area of that base, which is 43.5. And so my surface area is 144 inches squared. Okay, so I just wanted to go back over that problem because I know in my first trial of this video it was not explained very well, so now you're going to go back to the original video. So I know that one is difficult. I'm going to give you a hint for number 5 actually. So you're looking at this, and I actually think number 5's picture is a little bit easier to look at. This would be your base down here. Let me get rid of all this stuff. This triangle all the way at the bottom, that's your base. Okay. Your height of your base is this 61 centimeters, so that's the height of your base. Your lateral area, or not lateral area, your lateral height, your slant height, I keep messing that up. Your slant height is 12.2. And you should be able to find every other piece of information, okay? So hopefully that helps kind of tone in on what's needed and what's necessary. We are going to skip number 6 because it does involve something that we didn't really covered completely with area last week, so we're going to skip number 6. Now, this back page is all about cones. So cones are pretty easy. They're a lot like spheres, or not spheres, cylinders, like what we did yesterday. So I think if you understand this idea of a slant height, you should be able to pick up cones pretty easy. I think the one that we're going to have the most trouble with is pyramids. But you're going to do number 8, and I'm going to do 7 and 9 right now. So with cones, you have to have your slant height again, like I just said, and that is this diagonal portion alongside the outside of the cone. And then you're also, again, dealing with the radius of the circle. That is the base of the cone. So you're coming up with that pi r squared. That's, again, your area of a circle. So you're finding this area of the circle. And then the other part of the cone that you need for the surface area is coming from this pi times r times the slant height. So looking at number 7, I'm given my radius is 7 meters. Let me type that out. So radius is 7. And then my slant height is 11.4. And then I do not actually need my actual height. So something that you don't need is this right now, because I just need my radius and slant height for this surface area formula. So surface area equals pi times r squared. So pi times 7 squared plus pi times 7 times 11.4. And so my surface area is 404.64 meters squared. And again, I'm using pi, so that's why if you use just 3.4, you might get a little bit off with your decimal. Okay, you should be able to do number 8, easy peasy. Just make sure you don't get mixed up and you only use the radius and not the full diameter. So in 9's a little different. 9, I'm given the height this time, and I'm not actually given my radius, so I don't know what this is. But if I take this triangle and I flip it upside down, this would be my radius, that I don't know. My height would be 25.2. And then my slant height is this diagonal in the triangle, so it's 27.3. Again, I'm dealing with a right triangle, so I'm going to use Pythagorean theorem to solve for x. This time x is one of my legs, so I'm going to have it first, x squared plus 25.2 squared equals that hypotenuse, which is 27.3 squared. When you subtract 25 squared from 27.3 squared, you get x squared to be 110.25. Take the square root of both sides, and x is 10.5. So that means my radius is 10.5. And then my slant height again is 27.3. So I can now use all of that to figure out how to get my surface area by taking pi times r squared plus pi times 10.5 times 27.3. Sorry, that got a little messy. And so the surface area turns out to be 1,246.9 inches squared for this one. And that's all we're going to do. Some messages about your attendance quiz. You're not going to be asked anything about the application problems. You are going to be asked about number 8, number 5, and number 2. And you're also going to be asked what this is. So if you're watching this video all the way through, you're going to be given a little bit of a hint, and you'll be able to for sure get that question right. So again, let me know if you have any questions. I'd love to hear from you guys. I'll talk to you later. Bye.